the homework up video, page 97. These numbers here, let's go ahead and jump right into this. Number 17 through 23. The directions say to sketch the graph of the inequality. So let's get right into this. First of all, step one is to draw or to graph the line. Pretend that you have an equal sign and graph this like it's an equation. So x equals 4. Now, we've been over this. If the equation has one variable, x or y, is either going to be horizontal or vertical. So the x has to be all by itself. If it's an x with no y anywhere, it's automatically going to be a vertical line. Got it? So I go to 4 on the x-axis and I draw a vertical line. Now it's going to be a solid line. And don't forget to check that it's going to be a solid line because of the equal sign right here. Okay? So step one is now finished. Step one is to graph the line. and to make sure when you graph it to check to see if it's dotted or solid. Okay? Now, next, step two, decide where to shade. If the line is horizontal or vertical, it's really easy to know how to shade. Just look at the symbol and you're good. X is less than 4. So we know we're going to shade over here to the left because going to the left is less than. And there we go, students. Just like that, we're finished. Listen, anytime you have a single variable inequality, in other words, the inequality has just an x or just a y, those are so easy and so quick. You're either going to have a vertical line or a horizontal line, okay? Let's try number 19. Okay, the first thing you do, don't forget, is pretend you have an equal sign. Even though you don't, you pretend that you do. That's easy. Now, if negative y equals 50, then y equals negative 50. Listen, students, don't think that you have a y equation with no x. So you go right to 50 and draw your horizontal line. You must make sure the y is all by itself. If there would have been a negative 2 right here, then you would divide both sides by a negative 2. Okay, if the inequality or the equation has just an x or just a y, that's great, but make sure it's all by itself. So negative y is not all by itself. So if negative y equals 50, then y equals negative 50. So we're going to have a horizontal line, okay, at negative 50. So let's just go ahead and pretend these are in increments of 10. We can do that. So we're going to say they're increments of 10. So 10, 20, 30, 40, 50. Here is my line right here, and I notice it's got to be dotted, okay? Because I notice, and it's really easy to forget to check, so don't forget to do that. But if you'll look right here, there's no equal sign under the inequality, okay? So there's my line. Now, next step, we have to shade. Anytime you have a horizontal or vertical line, it's really easy. Just look at the symbol. Now, in this case, though, I've got to say something. Boy, don't miss this, students. This is a tricky one. Y is not by itself. Okay, so hold on a second. We've got to divide both sides by a negative 1. When you do that, the arrow turns this way and you have a negative 50. Now, did you get that? Okay, y is greater than negative 50. Okay, y is greater than negative 50. Alright? Okay, look that over. Back it up and watch again if you need to. You don't know which way to shade until the y is all by itself. Okay, 12y is greater than negative 6. Alright, I'm going to divide both sides by 12. I guess I'll do that first. And I'm left with y is greater than negative 1/2. Okay, so I divided both sides by 12. I did not turn the arrow because we did not divide by a negative 12. It was a positive 12. Now, excuse me. Now we're going to rewrite this like there's an equal sign. We're going to pretend that we have an equal sign. So y equals negative 1/2. So go to the y-axis at negative 1/2 and draw your line. But hold it, there's no equal sign here. So it's going to be a dotted line, okay? And there we go. Now, y is greater than negative 1/2. Y is greater than negative 1/2. So we shade going up. And remember, the points on a dotted line are the solution. Points on a solid line like this are part of the solution. Okay, number 23. The first thing you want to do is get this x all by itself, since it is just a single variable inequality. So we'll do that quickly, and we're left with x is less than or equal to 1/3. Okay, so here we go. Now that we've got x all by itself, we're going to pretend we have an equal sign. X equals 1/3. Notice that we have one letter. It's an x, so we'll have a vertical line. A vertical line at, sorry students, a vertical line at 1/3. So I can see you have 1/3 here. Just to estimate it over here. It doesn't have to be perfect, okay? Just to estimate it will be a solid line. So I'm just going to do this real quick. Give me just a second. So you have a vertical line going through 1/3. Alright? So there we go. Now, then look at your inequality. X is greater than 1/3. So you are going to shade to the right. Okay? Shade to the right. And there we go. Alright, moving on to number 29. And we see right away, this is a two-variable equation. Got it? Two-variable equation. It has an x and a y. All the other problems had x only, y only, y only, x only. Okay, now we've got a problem that's x and a y. So we're going to pretend we have an equal sign like we're supposed to. And then we're going to graph this equation. Now, you can use a double intercept method, slope intercept, plotting points. I'm going to use the slope intercept. Do you know why I'm going to do that? Because y is all by itself. And if y is all by itself, then I know right away my constant term has to be my y-intercept. And my x coefficient has to be my slope. There we go. So there's my y-intercept and my slope. Piece of cake. Go to -5 on the y-axis. 1, 2, 3, 4, 5. Then from there I'm going to rise 3 and run 4. So rise 3, 1, 2, 3, run 4, 1, 2, 3, 4. Now, why did I go up and to the right? Because 3 is positive and 4 is positive. So positive is up and positive is to the right. And then draw your line. Now, I noticed before I drew my line to make sure that it was dotted, okay? It's dotted because there's no equal sign here. Alright, so there we go. Now, when your lines are horizontal or vertical, you don't need to test a point to see where to shade. Let me say it again. When your lines are horizontal or vertical, you do not need to test a point to know where to shade. You do not need to. However, if it's a slanted line like this one, you do have to test a point to know where to shade. So I'm going to test a point, and as I taught you in your notes, our most favorite point to test is 0, 0, whenever you can. Now, if 0, 0 falls on your line, then you cannot test that. You cannot use 0, 0. But other than that, 0, 0 is a great point to use. Sorry guys, my throat is bothering me. So where the y is, I put a 0. Where the x is, I put a 0. This is pretty simple. Anything times 0 is 0. 0 minus 5 is -5. 0 is less than -5. Think of a number line. Here's 0. Here's -5. Which number's further to the right? 0 is. So 0 is greater than -5. This is false. This says 0 is less than -5. That's false. So this point right here is false. So if this point doesn't work, then you definitely don't want to shade where that point is. You want to shade where that point is not. Okay? And so there it is. Okay? Alright, moving on to number 30. Same thing, I notice right away I have two variables, so I'm going to rewrite it with an equal sign, and I'm going to say to myself, okay, I can graph this pretty quickly. Y is all by itself, so if y is all by itself, I'm going to say my y-intercept is 10, and my slope is 2. I'm going to put that 2 over 1, so I have a rise number and a run number, alright? So my 8, 9, 10, 11, 12. All right, now, okay, so my y-intercept is 10, so I'll put a point right here. And then from there I have a positive 2 and a positive 1. So I'm going to rise 2, 1, 2, and run 1. And there we go, students. Just like that, I can draw my line. Now, before I drew it, I glanced over and noticed I have an equal sign here, okay? So that means I'm going to have a solid line, not a dotted line. Now, does 0, 0 fall on this line? Not at all. So let's test 0, 0 to see if we get a true or a false statement. So where the y is, I put 0. Where the x is, I put a 0. And here we go. 0 is greater than 2 times 0 is 0 plus 10 is 10. 0 is greater than 10. False. So this point here is false. So you do not want to shade where this point is. You want to shade where that point is not. So there we go, moving right along. These are not too difficult, okay? All right, continuing on. Number 31. Okay, right away I notice I have two variables, an x and a y. So I'm going to go ahead and rewrite this with an equal sign. Okay? There we go. Now, to be honest with you, personally for me, whenever I go to graph an equation that has an x and a y like this, my x here, then the y, then the equal sign, then a number over here. Whenever I have that situation, I personally love the double intercept method, but that's just me, okay? So, to find the x-intercept, I'm going to put 0 in for y. And by the way, on any of these last two problems, if you want to use table of values, or double intercept on these, feel free to. I'm just picking the method that I like to use. So I'm going to put a 0 in for y very quickly. 12 times 0 is 12. 4x plus 0 is, or 12 times 0 is 0. 4x plus 0 is 4x equals 3. Divide both sides by 4, and x equals 3/4. So just like that, I have the x-intercept, and it's about right there. Just estimate that. Now I'm going to put 0 in for x to get the y-intercept. 4 times 0 is 0 plus 12y is 12y. Divide both sides by 12, and 3 divided by 12 is 1/4. Okay? So, kind of weird, but we can handle that. There we go, okay? Now, my line's going to be dotted, okay? So, we'll quickly, actually for me, well, we'll just do it like this. With a mimeopad, sometimes it's easier just to draw the line like this, and then quickly just go like this. I know it erases part of the graph too. It's not the best way to do it, but it'll work. So, there's my dotted line. Now, I'm going to tell you something, students, and you better listen to me. When the line's really close to 0, 0, I don't like to use 0, 0. I just like to play it really, really safe. Now, you can use 0, 0 when the line's close to 0, 0. I don't like to. So I'm going to go up here, and I'm going to test this point, 2, 2. Why? I have no reason. I just think that 2 is easy to do, so, and it rhymed also. 2 is easy to do, so, alright, so where the x is, I'm going to put a 2. This is my x, this is my y. You can test any point you want. We've been using 0, 0 because it's the easiest. But you don't have to use 0, 0. So where the x is, I substituted a 2. Now where the y is, I'm going to substitute a 2. And obviously it's going to be true. 4 times 2 is 8. 12 times 2 is 24. Combine those two and you'll get 32 is greater than 3. And obviously 32 is greater than 3. So this point here is true. So if that point is 2, then I'm going to shade where that point is. So the answer to this inequality is all the points up here, but not the points that fall on the line, because it is a dotted line. Alright, number 32. Here we go again. I see right away that I have an x and a y in my inequality, so I'm going to rewrite the equation, or the inequality, excuse me, with an equal sign. Now I'm going to graph sign than a number, so I'm going to use the double intercept method. So where the y is, I'm going to substitute 0. Negative 6x plus 0 is negative 6x. Now divide both sides by negative 6. Now be careful. A positive 3 divided by a negative 6 is negative. 3 divided by 6 is 1/2 or 0.5, whatever you want to put. So there's my x-intercept, negative 1/2. Now where the x is, I'm going to substitute 0 to find my y-intercept. So I'm still using my imaginary equal sign. Here's my x, I'm going to put a 0. 6 times 0 is 0. 0 plus y is y. Y equals 3. So the y-intercept is 3. Now it will be solid, so let's draw that solid line, okay guys? If we're able to. It's not easy to do with this mimeopad, but we'll do it close enough. It's really not straight, but it'll do. Now again, you do whatever you want. We're pretty close to 0, 0. I'm just going to hop over here and test a point that's not even close to the line. I like 2, 2, or 1, 1, or 3, 3 for many reasons. First of all, if both numbers are the same, like 2, 2, there's no way you're going to make a mistake. Like if your ordered pair was 2, 4, you might get confused and put the 4 in for x and the 2 in for y. Okay, so that's one reason I like to use ordered pairs with the same number. Secondly, they're both positive, which eliminates mistakes that might happen sometimes when dealing with negative numbers. So that is why I'm using 2, 2. So you could use 1, 1, 3, 3. I just think 2, 2 is a good distance away from the line. Probably 1, 1 would have been fine also. In fact, to be different than the last problem, I'm going to go ahead and use 1, 1. Alright, so there we go. So we're going to test 1, 1. So where the x is, I substitute 1. Where the y is, I substitute 1. And let's see what happens. Negative 6, positive 1. That would be negative 5 is greater than 3. Now think of a number line. Here's 3, here's 0, here's negative 5. Which number's further to the right? 3 is. So 3 is greater than negative 5. 3 is greater than negative 5, and this says 3 is less than negative 5. That's not true. This point here is false. It does not work. So I'm going to shade over here where the area is true. So the answer to this, the points that satisfy this inequality, are all the points in the shaded area plus all the points that fall on the dotted line, because it is a solid dotted line. Plus all the points that fall on this line, because it is a solid line. All right, number 33. Again, repetitive, but good practice is practice. So I'm going to rewrite my inequality with an equal sign. I'm going to pretend I have an equal sign. And now I have x then y then an equal sign then a number. So for me, I really like the double intercept method. It's fast, okay? So where the y is, I'm going to put a 0. 5 times 0 is 0. X minus 0. X minus 0 is x. So x equals 15. Okay? We're going to do this in increments of 3. So 3, 6, 9, 12, 15. Alright? So increments of 3. Now we're going to put 0 in for x. So here's x. I'm going to put a 0. Keep your equal sign still yet. We're still using our imaginary equal sign. 0 minus 15. 0 minus negative 5y is negative 5y. Now, be careful here. You have a positive being divided by a negative, so that's a negative, and 15 being divided by 5 is 3. So your y-intercept is negative 3. Now don't go down here. Remember, we said our tick marks are going to be in increments of 3. So this is 3 right here. Now you have an equal sign right here, so it is going to be a solid line. So draw your solid line. Alright. And there we go. Okay, now we have to know where to shade. I think we can use 0, 0 in this problem. It's pretty far away, far enough. So we're going to test 0, 0 to see where to shade. Where the x is, I put a 0. Where the y is, I put a 0. And now let's see what happens. 5 times 0 is 0, 0 minus 0 is 0. 0 is less than 15. Well, that's true. 0 is less than 15. So this ordered pair right here is true. So we're going to shade where that point is. So all of the points that satisfy this inequality lie in the shaded region, plus on your dotted or plus on your solid line. Alright, number 34. Alright, here we go. Again, right away you should notice you have an x and a y. So I'm going to replace that with an equal sign and graph the line. Now we can do this pretty quickly using the double intercept method. Where the y is, I'm going to put a 0. 7 times 0 is 0, so 7x minus 0 is 7x. Now divide by 7, a negative divided by a positive is negative. 21 divided by 7 is 3. So my x-intercept is negative 3. Now let's substitute 0 in for x. So here's my x. 7 times 0, negative 7y equals negative 21. 7 times 0 is 0. 0 minus negative 7y is negative 7y equals negative 21. Divide both sides by a negative 7. And a negative divided by a negative is a positive. And 21 divided by 7 is 3. Alright, so there we go. Positive 3. I do not have an equal sign here. And so I'm going to go ahead and draw my dotted line. And now let's go ahead and test a point to see whether or not, or to find out where to shade. So 0, 0 is right here. It's a great point to test, in my opinion. So 7 times 0, negative 7 times 0 is greater than negative 21. 7 times 0 is 0. 7 times 0 is 0. 0 minus 0 is 0. 0 is greater than negative 21. That's true, guys. Here's 0 over here. Is negative 21 over here. 0 is more to the right. 0 is greater than negative 21. So this point is true right here. So because it's true, we're going to shade right here. Okay. So the answer, or the ordered pairs that satisfy this inequality, are all the points in this shaded area, plus, or not plus, the ones on the dotted line are not part of your solution set. So the answer to this inequality are all the ordered pairs in the shaded area, not including the ones lying on this line. Okay, number 35. Now, I want to caution you on number 35. You can use the double intercept method, but right away sometimes there's going to be exceptions. I can see right now the x-intercept is going to be negative 1/9, and the y-intercept is going to be negative 1/3. So you're going to have like a point right here at negative 1/3 and a point right here at negative 1/9. That's pretty hard to draw a pretty good line. So you've got to learn to use common sense when you're choosing your method. Now, are you saying, Mr. Earhart, that if we would have used double intercept on a test or a quiz, you take points off? No, you can do that. I'm just trying to get you to make good decisions so later on in math, whether it be in college or wherever, you have a good understanding and common sense as to when to use certain situations. So I really am not sure exactly what to recommend. I'm going to recommend a table of values on this one. So I'm going to take my equation. It's going to be a little bit of work, okay, so get ready for that. And I'm going to do my table of values method. And for x, I'm going to substitute 0, 1, 2. So let's get started. Where the x is right here, I'm going to put a 0. 9 times 0 is 0. 0 plus 3y is 3y. I'm a step ahead of myself. There we go. Divide both sides by 3. A negative divided by a positive is negative. 1 divided by 3 is 1/3. So there's one ordered pair. Okay. Now let's substitute 1 in for x. So 9 times 1 plus 3y equals negative 1. Now 9 times 1 is just 9. Bring your 9 over. I would say, Mr. What are you doing? Well, look, guys, I put a number in for what? X. Now I've got to solve for y. I have to know what y equals, or I can't put my value in over here. So I put in a 1 for x, and now I'm going to solve for y. So 9 times 1 is 9. Now bring your 9 over, make it a negative 9. So you're left with 3y equals negative 10. Okay? Now divide both sides by 3. And of course you have a negative divided by a positive is a negative, and 10 divided by 3 is 3 1/3. So next is negative 3 1/3. Now if my pattern's correct, the next number is going to be negative 6 1/3. Let's see, where the x is, I'm going to substitute 2. Here's the x, because I substitute 2. 9 times 2 is 18. Bring the 18 over to the other side and make it a negative 18. So 3y, and I should put an equal sign here. 3y equals negative 19. Divide both sides by 3. A negative divided by a positive is negative. 19 divided by 3 is 6 and 1/3. So we're good. So now simply plot these 3 points and sketch your line. When you sketch your line, notice you have an equal sign here, so it will be a solid line. So 0, negative 1/3, 0, negative 1/3. Over 1, up, down, negative 3 and 1/3. And then over 2 and down 6 and 1/3. And so there's the line right there. Alright. And I'm not very good at drawing these, but you get the point. Okay, you can use a straight edge and make sure your lines are good and straight. There we go. It's going to be a solid line, and there it is. Now, next, we have to test a point to see where to shade. I could use 0, 0. I'm going to jump up here to 1, 1, just to get away from the line. So where the 9 is, I'm going to put a 1. Or where the x is, excuse me. Where the y is, I'm going to put a 1. And now let's see what we get. 9 times 1 is 9. 3 times 1 is 3. 9 positive 3 is 12. 12 is less than negative 1. That's false. 12 is not less than negative 1. 12 is greater than negative 1. So this point here is false. So I'm going to shade over here. So all of this area, infinitely going on and on, all of these ordered pairs satisfy the inequality, plus the points on this line also satisfy the inequality. Alright, number 36, our last one. Okay, this will be perfect for double intercept. Where my inequality is, I'm going to put an equal sign. And here we go. I'm going to substitute 0 in for y to get my x-intercept. So where the y is here, I'm going to put a 0. 4 times 0 is 0. 2x plus 0 is 2x. Divide both sides by 2. A negative divided by a positive is negative. 8 divided by 2 is 4. So I'm going to go to negative 4 on the x-axis. Now let's find the y-intercept, okay? The y-intercept. So, there we go. So in order to find the y-intercept, we're going to put 0 in for x. 2 times 0 is 0. 0 plus 4y is 4y. Divide both sides by 4. A negative divided by a positive is negative. 8 divided by 4 is 2. So y equals negative 2. Now it will be a dotted line. There's no equal sign right here under the inequality. So I'm going to go ahead and put my dotted line right here. And there we go. Now, next we got to decide where to shade. And of course we're going to test the point to do that. We're going to test our good old standby here. 0, 0. So where the x is, I'm going to put a 0. Where the y is, I will also substitute 0. 2 times 0 is 0. 4 times 0 is 0. 0 plus 0 is 0. 0 is less than negative 8. Now think about that. Here's the number line here, 0. Here's negative 8. Which number is further to the right? 0 is. So 0 is greater than negative 8. 0 is greater than negative 8. Alright? So this point here is false. So this point right here is false. So we're going to shade where the point is not. So the answer to this inequality would be all of the ordered pairs in the shaded area, not including the ones that lie on the dotted line. Okay? And that's it. So guys, we've really been going over graphing these inequalities, and hopefully this is making sense. Okay, real quick review here. Remember, if your inequality has one variable, like this one, this one, this one, or this one, you're going to have either a horizontal or a vertical line. Okay, very important you see that. And then when you have the double variable inequalities, you graph them as a slanted line using either the double intercept method, the table of values method, or the slope intercept method. Okay, I hope this video has been a help to you guys. Never hesitate to contact me if you have any questions at all.